Hi, my name is Jacob Parks, and I'm graduating from UAT with a bachelor's in robotics and embedded systems. My SIP project I'm showing you today is called Live Witness. Live Witness is an autonomous quadcopter that can give the user limited control via Wi-Fi and provide first-person camera view of what's happening on the quadcopter. It will also have AI spatial mapping to help it avoid obstacles and then return to the path it's on. I'm hoping that I can use this project in venues such as concert halls, museums, and tourist attractions. And the user would be able to select different locations and viewing angles and get little audio clips on what they're looking at, or just view it and enjoy the show. So, setting out on this project, it was the first time I'd tried to do anything with drones or quadcopters or any sort of flying machine. First step, I kind of set out trying to figure out what parts I would need, and I was surprised at how many just different options there were, all sorts of different sizes, different power levels, battery sizes, weights, and what they could all do. So it took a lot of research to just figure out what I would need for my project, what would work best. And once I kind of got that narrowed down, I tried to figure out how I was going to wire it all together, be able to power everything. And then once I got it kind of mapped out, I set to work teaching myself to solder, got it all hooked up, built up, and ready to go for its first few test flights. And here we were able to see one of its many little test flights. We were trying to get everything balanced and figure out how it was going to fly. It went through many of these, and we had quite a few mishaps, burnt wires, bent propellers, broken parts. So this stage took a lot longer than I expected, but eventually we did get it flying and moving along the way it should. I figure there's three main components to how this quadcopter works and is able to fly itself. Most of the code is controlled by the Arduino, and the balancing and all the gyroscopes is done by the MPU 9265. It's actually a 6-axis accelerometer and gyroscope, as well as a compass on there. And it's able to do this by moving little parts around on the inside and sensing the different motion. Some of the data we're able to send back and forth looks kind of like this, where we have a timer on the far left, and then you have your x-axis, your y-axis, and your z-axis, and then I just outputted a simpler, easier to read what the quadcopter is actually doing in the moment. And all the communication between the Wi-Fi and the quadcopter itself is handled by an ESP32. So now I'll move into some of the cool things that can do. So on the left here, we have a video of the AI training. We did the training level in Unity, where it's just kind of doing a mock drone flying around a room and learning the different movement, how the chairs look at different distances and how much they move compared to how much the drone moves. And we'll use this to help control its and let it know its orientation. We use React to help display some of the Wi-Fi data to the user. This is just a simple picture of the gyroscope data. And then all the flight controlling code is handled by the Arduino. Here we have a simple version of what the website would look like for the user, with different buttons that could control the drone and just send it to specific locations. In the middle we have a camera on the quadcopter, see what the person would see as they're flying around. And then on the right we just have some mock data of what the gyroscope is sensing as it flies. And as a final note, I would just like to thank everyone who helped me on this project. Cody Mitchell, Benjamin Branch, Matt Evans, and Matthew Prater all did an amazing job of helping me when I got into trouble, and just, yeah, all around great assistance. So thanks again, guys. And that's my project.